So, how did banded iron formations form? Well, the story begins a long, long time ago, way back in the Precambrian eon. And back in the early days of the Earth, the atmosphere was composed mainly of CO2, carbon dioxide. We still had oceans, and we still had land, and rain fell on the land, and that caused weathering to occur, which washed some materials into the ocean. And some of those materials were very soluble in the absence of oxygen. And those were things like silicon and iron, Fe, the symbol for iron. So for a long time, the atmosphere had no oxygen in it, and so the water was able to absorb large quantities of iron and silicon. And then a strange thing happened, which was that plants evolved, or at least algae. And when those little bits of algae in the water started to function, they took that CO2 and they turned it into oxygen, O2, which they are still doing today. And that oxygen went into the atmosphere, and it also went into the oceans. And in the presence of oxygen, iron and silicon are no longer stable. Instead, what happens is they are going to precipitate, and they're going to form layers on the bottom of the ocean of a couple of different minerals, things like magnetite and chert. Magnetite is an iron oxide. Chert is, of course, silicon oxide. And so the magnetite and the chert, and also there's probably some hematite. And hematite's another iron oxide. And those formed layers here on the bottom of the ocean. And what those look like now is this. So this is a banded iron formation. And this formed a long time ago. And in most places in the world where this has formed, it has since eroded or it is not exposed. And there are really only a few places in the world where this really good high-grade ore was discovered, and one of them was northern Minnesota. And so in northern Minnesota, miners very quickly started to mine all of this really good high-grade ore. You can see these gray layers in here, and those are composed pretty much of straight magnetite and hematite. And there's only a little bit of the more problematic chert in there. Well, they pretty quickly ran through all of the really high-grade ore that they could find, and they were faced with the end of iron mining in Minnesota. And so they turned to the University of Minnesota, and scientists at the University of Minnesota decided that they could come up with a process for extracting the hematite and magnetite from a lower grade ore. And I've got some of that lower grade ore here, and you can see what that looks like. It's just not really the same as this stuff. It's got some iron in it, maybe about 30%, but it's not really high grade. And then what they did is they take that low grade ore, and through a process of grinding, they grind it up into this powder and then extract the magnetite using big magnets. And so they're able to separate the ore minerals from the gangue minerals, or the chert, the silicon stuff. And so that comes out, and then you're left with this powder, which is then combined with a little bit of clay and rolled around to make these, which are taconite pellets. And these pellets are what we now ship around the world. So now this process of extracting the ore, processing it, separating the good stuff from the bad stuff, and then making it into these pellets is pretty big business up there on the Iron Range. So northern Minnesota's economy is heavily dependent on the extraction of these taconite pellets. And generally, it's not that bad for the environment. Taconite has a lot of oxygen in it, but not a lot of other elements that could be more problematic. So generally, it's fairly benign, and we've been doing it for a long time, so we know pretty much how it goes. And that's about it as far as the iron mine in northern Minnesota. Thank you.